but today we're going to solve equations again, but now we're going to deal with distributing. So if it's distributing in the title, what does that mean?
You're going to distribute.
Yeah, but what does that mean?
You use multiplication.
Okay, and I'm going to use multiplication in why? Because of what tells me to use multiplication. The parentheses, right? So remember when we started doing all these problems, we went through a process called PEMDAS,
Yeah.
right? And the first letter is always what?
Parentheses.
The parentheses. And what did we always say when we were working with our parentheses? We're going to do them first, but we should always try to work where?
Left to right.
How about inside out, right? We're going to go inside the parentheses, simplify anything in there, and then work our way out. Well, most of the time today when we have parentheses, we're not going to have to do anything on the inside, so we're going to do our distributing process. Not yesterday. Friday, when we started this section, or this chapter, we were talking about solving equations, and we came to the conclusion we still want to have what happen at the end. Our variable to be what?
Positive and isolated.
And all alone, right? And positive. Okay, so that still has to be. And then if you remember on Friday, we started listing things that you should do every single time that you do an equation. And that number one thing is to get rid of your parentheses by distributing. So we're actually going to look at problems like that today. And then number two was to combine like terms. And that's what we really focused on Friday. So you're still going to have to do what we just got done correcting in the assignment. But before that, you're going to have to distribute. Okay, so biggest thing here is we want to get rid of the parentheses in our problems. And then we're going to go through and do the problem like we did on Friday. So we start out nice and simple. 3h is equal to 5 parentheses h minus 2. So again, every time that you have parentheses, I would still look inside just in case there's something I can do. So if I can combine like terms or do something, if there's multiple things happening on the inside, maybe there's multiplication that I possibly could do, you still got to do it. In this case, can I take h minus 2? No, we have a horse and a person, right? We can't subtract those together. So we're going to distribute. Remember when we distribute, we take the number on the outside and multiply it to every single term on the inside. But don't forget about the signs in front of those numbers. So when I distribute, I'm taking 5 times -2 in that second part, right? Don't forget that. So we rewrite. Again, make sure you're showing your work. What do we get when we distribute?
5h minus 10.
Perfect. Now we're right back to what we were doing the other day, right? So, which way do we take our h's? Do I take my h's to the right or to the left?
To the right.
To the right, because we always want to try to take the smaller one towards the bigger one. So, 3h was positive, so we're going to subtract it from both sides. And again, if you want to do this step at the same time, because I'm moving my h's to the right, I got to move my numbers to the other side. So I'm going to add 10 to both sides. My h's over here, they have the same coefficient, but they have different signs, so they cancel out. Same thing with my 10s, same number, but they have different signs, so they cancel out. 0 is, or there's nothing above this 10, so it's really a 0. 0, and we get 0 plus 10. And then what's 5h minus 3h?
2h.
2h. And how do I get h alone?
Divide.
Divide by 2. So what's h?
H equals 5.
H equals 5. And again now, should I realistically miss any of these problems?
No.
Because why? I can plug it back in, right? Again, remember, my goal is that the h is positive. It does not matter what the number is. I'm only worried about my variable. Okay? Questions here? So, that's basically our simple problems. Now let's try to get a little complicated. So let's go to this one first. Let's do this one. 2 parentheses, d plus 6 is equal to 3d minus 1. So the only thing that's different here is now we got a number over here with my second variable. So again, we're going to distribute. So what do we get?
2d
Plus 12, awesome. Equals. Everything else stays the same, right? Which way am I moving my d's? To the right, right? 2d smaller than 3d. So this is a positive, so I'm going to subtract 2d. And again, if I want to do this at the same time, then I'm going to move my numbers to the other one. Now again, if that step bothers you where you combine them or where I'm combining them, just yell at me and we can do it separately too. So again, my 2d's cancel each other out. We get 13 equals over here.
Just one
D and nothing, right? So we're done. So that one is actually a little simpler than the other one. Okay. Any questions there? So, what about this one? 6k minus 2 equals 3k plus 8.5. So when you see this decimal here, realistically we should stop and think about what we were talking about the other day, right? Friday, and what we kind of talked about when we did the problems at the beginning. It's probably easiest to just get rid of that decimal so you're not having the decimal in the problem. Now here's the question. If I go about the same thing that we were talking about, getting rid of that decimal, I would multiply this by what? 10, because my decimal is in the 10th spot. But can I do that in this problem right here? Not yet, because my decimal is inside my parentheses, right? So realistically, I got to get this out of my parentheses before I can do that step of multiplying. So let's distribute on both sides. Okay? What do I get on this side? 6k minus 12. And on the right-hand side?
3k plus 25.5.
And then this is where you might have to use your calculator, right? Punch that into 8.5 times 3. So now we're able to do what we were talking about by getting rid of the decimal. Okay, so again, put your parentheses around the whole thing. And you told me we're going to multiply by 10?
Yep.
Everybody understand why it's 10? Okay? Because there's only one decimal place, right? And that's the 10th spot. So if this would have been 2 decimal places, this would have been 0.57, then the 7 would have been in the hundredths, and we would have multiplied by 100. So now distribute. What do I get?
60k minus 120 equals 30k plus 255.
Now, the only difference is, when you do this, notice my numbers, they got a little bigger, right? But don't let that fool you. Try to finish the problem. See what k is. This one I'll do in 2 steps, just to show you that it doesn't really matter. And again, maybe you punch this into your calculator to get a decimal, but realistically, I would just leave it as an improper fraction, although I want to reduce. So, can I take, obviously, a 5 out of this? 5 times 7 is 35. 75 over 6. Is that all?
You could take,
Nope.
yeah, the two.
Then I can take 3 out, right? So I get 3 quarters and I get 25 halves. Bless you.
Yeah, so I got 12.5, so I just divided it.
Perfect. And then if you divide, okay? And again, if you divide and get a decimal, it's not that bad. But if you get really far into, if you get into pre-calc and that kind of thing, it's a lot easier to use your fractions than it is your decimals. Okay? But it'll never be counted wrong. So, everybody okay with that? Distributing, okay? I'm trying to figure out which way I want to go here. Let's go with this. From here, then, we have 2 special cases. Anytime that you hear 2 special equations, you should automatically think of, I'm going to have either a lot of answers or I'm going to have no answers. Okay? So, in my 2 special equations, we could have an infinite number of answers, or we could have no solution, which means there is not an answer to the problem. Okay? So, how is this going to happen? I'm going to go through the process of solving these problems just like we've been doing. But at the end, instead of having a variable equal to a number, somehow the variable is going to get canceled out. And you're going to end up with just numbers at the end. Okay? If you end up with an infinite amount of answers, an infinite amount means what? It doesn't end. Okay? In this case, an infinite amount means that I can put in just about any number, or not just about, I can put any number into the equation, and it makes sense. It works. So I have an infinite amount of answers. No solution would mean if I put a number in there, it's never going to work. Okay? So I'm going to go through the process. My variable is going to get basically canceled out somehow. When I bring it to the one side, it's just going to cancel it out. To get an infinite number of answers, I'm going to have some number equal to itself. And when you get some number equal to itself, it automatically tells you that you have an infinite number of answers. I can put any number in there. It does not have to be 3. It can be whatever number it is. 13 is equal to 13. Okay? If the sum number is equal to itself, you have infinite numbers of solutions. If you have no solution, you have some number, but it's equal to something else. Okay? And again, it does not have to be those numbers. I just picked those numbers out of random. So, to answer this, then, you would give a symbol for each of these. What's the symbol for infinity?
It's like 8 on the side.
Yeah, sideways 8. So, we would just write that as my answer. And what is the symbol for no solution?
Is it a 0 when the comma's on?
Perfect. No solution looks like this. Circle with a slash through it. Okay? So, how do we get these, or what do these look like? These look like this. So we just have a problem again. We go about doing the problem just like we've been doing it. Okay, so I look at my problem, I see parentheses, I automatically know I got to get rid of my parentheses. So distribute right here, and we get what? 12x minus 6 plus 15 is equal to 12x plus 9. Now, before we try to get our variables together, I'm going to simplify the numbers that are on the same side. And because they're on the same side, I just do what they say. So what's negative 6 plus 15?
9.
9, right? And it's a positive 9. Oops, I got max. So if you're not going too fast and you stop and just look at these two right here, notice that what's on the left-hand side is the exact same thing as what's on the right-hand side. Okay? Now, if you're going fast and you're trying to go through the problems and get your variable loan, that's fine. If I try to get my variable loan, it doesn't matter which way I move it, I'm going to subtract 12x from both sides. They cancel each other out, and I'm left with 9 equals 9. So what's my answer? Infinite number of answers. So, let's prove this to each other. Everybody pick a number. Don't tell me what your number is. And stick it into the equation on both x's and solve. Okay? So everybody pick a number right now in your head. A small number. Yep. So, now take that number that you just picked in your head and put it in for this x and solve the problem. See what you get. Go. Pick some number. Pick one, I don't care. And then we're basically going back to the order of operations, right? And this. So I picked 2. I got 33 is equal to 33. Trevor, you did 1. What'd you get? 1 equals 1. Somebody use a different number besides 1 and 2.
Brady, what'd you use?
You used 1?
Yeah.
Okay. So, does everybody agree that it worked? And again, so, this just proves that whatever number we throw in there, it should work out. Okay? You want to do one of these kind of by yourself? Yeah? Alright. So, let's try... Three parentheses 2g plus 4 equals 6 times g plus 2. What'd you get? You got what?
Infinite.
You got infinite? You got 12 equals 12?
Yeah, I got 0.
Let's try it out. 6g plus 12 equals 6g plus 12, right? So again, if you want to do it one more step, or if you can notice right here when they're exactly the same thing, either way it's going to come up being infinity. So again, if we would have ended up with this, and our 6g's was the same, and again, this isn't how this was, but I subtract my 6g from both sides, and I end up with 12 equals 13, that's my other case, right? And then we would say it's circle with a slash. No solution, empty set, those all mean the same thing. Okay with that?
Yeah.
All right. Now, one last thing they talk about in this section is perimeter. What's the perimeter of a shape?
Outside.
The outside, right? Adding up, going around the outside. So, if I had the perimeter of a rectangle, for instance, everybody understand what a rectangle is? A rectangle looks something like this, right? Okay? And so a lot of times they say that this is the length and this is the width. Do you agree with that? So one way of saying this would be that I have W plus L equals capital P. Agree with that? Or we could simplify this and bring these together and say that we have 2W plus 2L is equal to P. So all that we're trying to show you is that you could kind of go through and do distributing to get to this formula. And you can use either of these formulas from here on out for perimeter. It's totally up to you. All right, but all they're trying to show you is that you could rewrite the perimeter formula using distributing if you wanted to. But again, every time that you hear the word perimeter, you should just think about going around the outside. Okay? So I just wanted to mention that because I think you got to do a couple of problems in the homework. Over here, for the very beginning, any questions with any of those kinds? Anybody need to see more examples? Everybody good? All right.